who's not well known enough as far as I'm concerned. He built the world's first transistorized computer in Manchester. He was himself a tutee of Alan Turing, which makes me a grand tutee of Alan Turing. And in fact, my second job, purely by coincidence, was to go to Manchester and work on the fifth computer, MU5, in the series of computers that Turing had originally worked on, implementing Algol 68, actually, on that computer. I went on a sabbatical to Amsterdam, where I've been for the rest of my life. I co-designed the language that Python is based on. CWI, where I work, started the open internet in Europe, which made me, purely by chance, the first user of the internet, open internet in Europe. The guy in the office next to me implemented it, did the work, and he knocked on my door and he said, "The internet's up," and so I logged on, and that made me the first user. I consequently organized 2 workshops at the first web conference in 1994. I ended up for 10 years at W3C, where I co-designed CSS, HTML, and a whole bunch of other standards while there. So this is a typical project meeting at the CWI. That's Guido van Rossum in the middle there, the inventor of Python. That's me there, if you don't recognize. And there's a picture of me with Tim Berners-Lee discussing the future of HTML on a snowy Boston winter's day. Okay, so 30 years ago, last November, was the day that the internet came to Europe, the open internet came to Europe. And I would contend that we can still consider the internet as something new. But the funny thing is that on that day, 30 years ago, public computing was only 30 years old. In fact, this is a picture of the first time a municipality installed a computer, amazingly enough in Norwich in the UK. It was an enormous thing. This is just one of the 21 cabinets making up that computer. Now, 58 years later, another milestone in computing. That's the same building, by the way, and the same door. In 2015, the Raspberry Pi Zero was released, which was the first computer that was so cheap that they gave it away free on the cover of a magazine. So how do those 2 computers compare? The Elliott ran for a decade, 24 hours a day. So how long do you think, as a gut feeling, would a Raspberry Pi need to replicate the amount of computing? Do you think it's 10 years? This is going approximate orders of magnitude, 1 year. Do you think it'd take 5 weeks? Well, no, it takes 5 minutes to replicate what that original computer could do. And that's because the Raspberry Pi Zero is about 1 million times faster than that computer in 1957. So, but the Raspberry Pi is not only 1 million times faster, it's also 1 millionth of the price. So that's a factor of 1 million. Now, a terabyte is 1 million bytes. We talk in very large numbers these days, but we don't really grasp, I would say, how big these numbers are. So how long do you think 1 million seconds are? How long would it take you to count every single byte on a terabyte disk? The answer is 30,000 years, because 1 million is an enormous number. Funnily enough, 1 million is roughly what you would expect from Moore's law over 58 years, except that the Raspberry Pi is actually 2 million times smaller as well, so it's even better than that, even better than Moore's law would have predicted for the improvement over 58 years. And by the way, just as a side issue, for those people, if you ever hear somebody say that Moore's law is dead, that's because they're talking about the wrong thing. The blue line, which is the second one there, if you're colorblind, is what people often refer to when they're talking about Moore's law being dead, or maybe the green one, which is the third line. But Moore's law is actually the orange one, the upper line there, and that's most certainly not over yet. So anyway, 1957, computers were so expensive that nearly no one bought them, that you would lease them. And if you wanted to rent time on a computer, well, it would cost you of the order of $1,000 an hour, which was several times the annual salary of a programmer. That was an enormous sum of money. And that was because the amount you were paying was the equivalent to how much work, how much you would have to pay employees to do those calculations. And that's why it was so expensive. Now, when you leased a computer, as part of a sweetener for the deal, you got programmers into the deal. So if you leased a computer, you got a couple of programmers who knew already how to use the computer, because in those days, every computer was different, every instruction set was different, and so it was great to have somebody in-house who could already start programming and could also train the other programmers. So the basis, the bottom line here is that compared to the cost of a computer, in those days, a programmer was more or less free. Which meant that in those days, when a programmer programmed, well, first, because the computer's time was expensive, the programmer would write the program on paper and then copy it out on special paper, which would then be given to a typist who would then type it in and then give the results of that to another typist to type it in again to make sure it was typed in right the first time. 3 people. Why? Because that was still much cheaper than letting the computer discover the mistakes in the typing. Funnily enough, well, not funnily enough, but at that time was when the first programming languages were designed. So we're talking about COBOL, Fortran, Algol, and Lisp, all created in the late 50s. And they were designed with that economic relationship in mind. The fact that the computer was the expensive bit and the programmer was the cheap bit. So it was much cheaper to let the programmer spend lots of time programming so that the computer could do as little work as possible. And so programming languages were designed to tell the computer exactly what to do in its terms and not what you wanted to do in your terms as a programmer. 1968, 10 years later, was the first time that software crisis as a term was introduced by Dijkstra, if I'm not mistaken, who comes from where I work as it happens. Programs that were being written weren't functional, they weren't being delivered on time, they weren't doing what they were required to do. It was a crisis, it was actually talked about in a crisis. Now, it's happened very slowly, almost unnoticed, I would say, but nowadays we have the exact opposite position. Compared to the cost of a programmer, a computer is almost free. And I call this Moore's switch. Here's a sort of a rough diagram of the relationship in the price of a computer and a programmer between 1957 and now. But the thing is that we're still programming computers in programming languages that are direct descendants, you can still see the family resemblance, to the languages designed in the 1950s. We're still telling computers exactly what to do. We're not describing our problem, we're still stepwise instructing computers on what to do. So I was kind of surprised when I saw the call for papers for this conference that it mentioned lots of programming paradigms, but it didn't actually mention declarative, which is why I called this talk what I did. Because declarative programming actually is a paradigm that gives you lots of advantages. And I want to describe the generality of declarative programming and then give you one example of a language. So the first time in your life that you come across a declarative definition is when you're told what a square root is. At school, you're told what numbers are and how to add them, how to multiply them, how to divide them. But when you get to square roots, you never learn how to calculate one, except for pressing that button on the calculator. You're just told that a square root is a number that if you multiply it by itself, you get the original number back. Now, it's simple, it's short, it's obvious, it's understandable. Everybody understands this at school. But it tells you how to recognize the square root, but not how to calculate it. And nobody learns how to do that. But if I show you the procedural code to calculate a square root, it's next to impossible to discover the relationship between the declarative concept of square root and the procedural way of doing it. In fact, if I hadn't told you that this was for square root, the chances are you wouldn't have been able to easily work that out. And in fact, what does it do? Under what conditions? How does it do it? Is the theory applied? Is it correct? Can I prove it? Under what conditions can I replace any bits of this? These are all questions that arise with a procedural bit of code implementing some concept. In fact, the theory has been applied here, but it's been optimized so that it's even hard to discover the theory because of those optimizations. The loop has been unrolled once constant expressions have been pre-evaluated. So what does declarative programming mean? Well, let me give you an example. Here is the smallest version of a procedural clock I could find at the time. It's 1,000 lines of C code for drawing an analog style clock on the screen. In fact, there are only 2 or 3 lines in that have anything to do with time at all. Most of it is all that administrative stuff that you have to do when you're programming. This was the smallest example I could find. I found one of 4,000, more than 4,000 lines. Now, if I wanted to do this procedurally, and this is an example from a running program, I would say a clock has got 3 fields, hours, and minutes, and seconds, and it's displayed as a circle around a combination of an hour hand, a minute hand, a second hand, and some decoration. And a second hand is a line of some length, rotated by the number of seconds times 60, and so on. So, and then I declare a clock, and I get the seconds and the minutes and the hours. And this is actually that thing running in 1993. This is running on a Sun workstation, but it also ran on an Atari ST, for instance. That bit of code you saw, well, it's actually a little bit more complicated, but that code shows you the essence of it. So that was 1993. So what I want to talk today about is XForms, which is a current declarative system. It's for defining applications. It's a W3C standard. It's been around for some time now. It's in worldwide use. I've got lots of examples of people who use it. The KNMI, which is the Dutch Weather Services, uses it. Many Dutch and British government websites run on it. For instance, legislation in the UK. The BBC, this is the BBC Sports app written in XForms. The UK NHS, I'm going to talk about that shortly. There's a whole bunch of organizations that use XForms. And I want to give you 3 examples of large projects that have used XForms and the advantage that they've got from it. So I'm not allowed to tell you which company this is because they're getting so much benefit from it that they don't want their competitors to know that they're using it. So imagine it's a shipbuilder. Now, when you build a ship, you build them one by one. Somebody comes along and says, I want a ship, and you say, fine, and he says, I want 1,000 bedrooms and 3 kitchens, 2 swimming pools, a cinema, and so on and so on. So every ship is built to very specifically. And of course, a ship has one control room that controls the whole ship, where everything can be switched on and off. You're coming into port with another 500 people coming on, you better switch on some more bedrooms, and we'll have another swimming pool as well. But of course, switching the swimming pool on means we'd better turn another generator on. So the connections, the constraints are very large. And they knew that, having done this very many times, that it took them 5 years with 30 people just to program the user interface of the control room. So 1 year they decided to try XForms out, and they did it in 1 year. Did I say 5 years with 30 people, and with XForms they did it 1 year with 10 people. So they've not only saved 4 years, but they've saved something like 14 million units of their currency, whichever current country they happen to be in, just by using XForms. Another example is the insurance industry. This was in the UK. This was a Scottish company, I believe, and the manager had heard about XForms, and somebody within the company had said, we really ought to try it out. And so he said, okay, traditional programmer, XForms, come back to me in 2 days and give me an estimate of how long it will take you to make this application. So 2 days later, the program said, 2 days not long enough to work it out. I need 30 days to work out how long it will take to program it. And the person using XForms had already programmed it, and it was running. My final example, my current poster child, is the National Health Service. They started a project for a national health record system. Which was very costly, billions of pounds, at least 70 programs involved. And they did produce a system, but the hardware costs alone were £5 per patient, and we're talking about 60 million patients here. And basically, it didn't function properly. So one of the guys who worked on this project said, I can do that. And he used XForms. The hardware costs are now down to 1 penny per patient. he can run it on Raspberry Pis quite functionally, and it's already been rolled out in 5 National Health Service hospitals. It's actually open source as well. My slides will be online shortly. You can click on that for the details. So let me tell you about XForms and what it is that makes it easy to use and reduces the time and cost of programming. So the original version, 1.0, was actually, as the name might lead you to expect, it was designed for online forms. But after some experience with that, we realized that with a bit of generalization, you could do much more with it, that we'd followed HTML a bit too slavishly. And so we created XForms 1.1 just by generalization, and that turned out to be Turing complete. We've got implementations from a number of languages. These 6 languages, 6 countries. These 6 countries are the ones that I know of that are active now. We're preparing XForms 2.0, so some of the things that I'm talking about today are actually XForms 2.0 features. But the system is in use already for some time. So just to explain now why we haven't changed the name from XForms, if you look at Wikipedia under form and content, you see that it says the term form refers to the work style, techniques, and media used, and how the elements of design are implemented, and content refers to the work's essence, or what is being depicted. Now, this is a perfect description of how XForms works, so we don't feel sorry about still using the word XForms. Think of form in that sense. Because XForms applications have 2 parts. They have the model, which describes the data and its relationships, and then the user interface, which is the content, and it uses values from the model. It's all about state. So you have state. You can get your data either internally in the program or externally from web resources or internet resources. XForms describes the data, the properties of the data, the relationships between the bits of the data. And you can display any of those values, of course, and change any of the values in the content. Initially, the system is in stasis, and if a value changes at any point, then using the description of the data, the system then updates other bits of data in order to bring the system back to stasis. It's very like how you expect a spreadsheet to work, except it's much more general. But it is very, very much like spreadsheets. What this means is that programming is much easier because the system does all the administrative work for you. You only have to describe your data, and the system does more of the work. So let me give you just a very small example, just to give you a taste of it. So I've got a position in the world as an XY coordinate, and I want to display the map tile for that coordinate. Okay, so my data is XY and the zoom that I want to display at. Now, luckily, OpenStreetMap has an interface for getting something like that. You just include openstreetmap.org and then the zoom and the x and the y and .ping, and you get that image. Now, the problem is OpenStreetMap, the coordinate system changes at each level of zoom because you've got twice as many, as you zoom in, you've got twice as many tiles in each direction, so you've got 4 times as many tiles as you zoom in, or half as a quarter as you zoom out. So to get the tile from the information that we've got, you have to know how big a tile is, and you have to calculate the correct tile index using your position in the world. So what you do is you calculate the scale, which is 2 to the 26 minus the zoom factor. Then you calculate the tile x and y from that, and then you construct the URL by concatenating the different parts. That is all you need to do. That is more or less the whole application. Of course, the syntax is slightly different because it's in XML, but that's basically it. And then the content, you just do your inputs and your outputs, and bingo, this is what it looks like. So we're looking at London here, so if I zoom in and hoping that the internet is working, yeah, it is good. And as I zoom out, and you can see there, I've also added the scales and the URL that's being calculated just to show you that it really is working. So that tiny bit of code is an enormously simple but useful piece that you can then combine into a whole application, which makes a slidable map. It's just using that bit of code and then a bit more code around it. In total, this is of the order of 100 lines of code. So in other words, I literally made this in a lunchtime. And if I want to make it more complicated, well, in fact, this single thing only changes the place where the tiles come from. So this changes a single value in the data model, the site that the tiles are being obtained from. And so when that value changes, then it goes and gets the tiles from a different location. So it was just a single control, nothing more to make it to make it hard to use. So let me just give you an overview of XForms. It separates, as I already said, it separates the UI from the data, and this is very similar to how CSS works, separating the style from the content, and it has similar advantages that you can argue. So you can get your data, so you get instances of data, so you can get it from externally, or you can actually put it inline there, and then you can bind different properties to things in the data. Properties include the types, constraints, relevance conditions, whether the data is optional or required, whether it's read-only or not, and it also allows you to calculate values based on other values. And as you saw in that example, whenever a value changes, the related values are updated automatically by the system to match. So you've described the state of the system, and if a value changes, calculations are done automatically for you. So let me just give a couple of examples of the properties involved. So relevant and required. So for instance, if you've got an address, you could say that the state field of the address is only required if the country is USA. And that would mean that the field will always be visible, but only if the value of the country is USA would the system require you to fill it in. On the other hand, if I said that the value is only relevant if the country is USA, but in that case it's required, then the state will only be visible if the country is USA, but once it's visible, it will be required. You bind then to that value, so you just say input ref equals address state, and that control then inherits those properties from the description in the model. So here, if I select a country, so if I select Netherlands, UK, USA, then up pops that thing because suddenly it's relevant and it's red because I've got to fill in a value. It's required, but not yet got a value. A similar use of relevance is you can have different addresses in your order form. For instance, you've got your postal address, but also your billing address, and the billing address is only relevant if the value of different is true. So here I've got the field that controls the difference, and as you can see, I just if the two are the same, then the billing address disappears. But I haven't had to do any work for that. The system has just worked that out for itself and said, okay, that we don't show the billing address because it's no longer relevant. So XForms works automatically like a spreadsheet, but sometimes you want to do a bit more. You want to hook into the model to respond in different ways that are not automatic. So just like inherited from HTML, you could say, you get events that tell you when states change within the model, and then you can use actions to affect states. So, for instance, there's an event that happens when the system is ready, when it's come up, and you can listen to that. And so if you wanted to set a value, a date of the value today, then you can just listen to that event and then use an action to set the value. Similarly, interaction is done using events, so that a raw button can listen to the event activate, so that when the button is activated, however it's activated, then it can respond to that event by setting a value, for instance, in this case, to a suitable value. One of the advantages of this is that this markup is completely modality free, that it works just as much with a voice input and voice output system as with a visual system on a screen like this, or and it can also easily adapt to different sizes of screen suitably, because the controls are also declarative. They say what the controls do and not how they want to do it. So that's done with in the content. The controls then are designed to be device and modality independent and describe declaratively what they do, how they do it, but not how they look. So here's just one example of a control, just selecting one of a list of values and being put into that the variable color. So this is the same control, just being represented in three different ways. So the first as a series of radio buttons, the second as a select list, and the third as a sort of menu. And so what you see is when I select red, then all the controls immediately react to that because the value has been changed, and so the controls have got to be updated. And if I step through the colors using the menu, using this menu, then you can see that the other ones respond similarly. But I haven't done any work there. I've just said it's 3 times exactly the same control, but just been given a different styling, so that you can choose either yourself how you would like this control to be displayed, or it can be modality dependent, so that if you go to a small screen, you use a menu, and if you go to a large screen, you use radio buttons. On the other hand, so that showed you the data actually being included in the control, but there's nothing to prevent you including all the control data in instances as well. So for instance, if you wanted to make a multilingual application, then you can just get your labels and everything else from a messages instance and respond suitably. So this would be how I would do it for the colors example. But to give you a real life example, this is actually a simplified version of a form that's actually being used by a company, so I can select something that needs to be filled in. But if I say, oh well, I'd rather have it in Catalan, then I can get it in Catalan or German or English or Spanish or French or Italian or Hungarian or Dutch or Chinese. That just shows you the languages that we have in my group at research group at work. The form hasn't changed. It's just getting its data from instance data. So my conclusion, I've gone a little bit faster than I'd realized. My conclusion is this, that for historical reasons, programming languages, our current programming languages, are at the wrong level of abstraction because they don't describe the problem, they just describe one particular solution. Declarative programming allows programmers to be 10 times more productive. So, and if I'd known about the Twitter meme of X10 this week, I might have called my talk something differently. But it allows programmers to be 10 times more productive. What you can now write in a week would take a morning, or what takes a month would take a couple of days. And I'm not just saying that, I'm saying that based on actual large projects that we've now seen people programming. I believe that declarative programming is an enormous future, and it doesn't necessarily have to be XForms, but as a paradigm for programming, it has enormous possibilities, and that once project managers can realize they can save 90% on programming costs, that they will, in the long run, switch to declarative programming. I believe that in the long run, and I'm talking about 100 years, everyone will program declaratively because you get fewer errors, you have more time available, you can be more productive, and it's just a great way to program. Thank you. So plenty time, questions?
Thanks, Stephen. That was great. I fully buy your argument that most programming is boring, and therefore you want to get the computers to do it rather than people.
Hang on. I can't hear you because of the echo.
Sorry.
So let me come a bit closer. Yeah.
Most programming is boring, and we want to get the computers to do it rather than wasting expensive people to do it. But some programming is interesting, so algorithmic bits of programming is interesting. You don't want to specify sorting and then get XForms to randomly permute your data until it's sorted. You want to think about sorting algorithms. How does that fit into this view of the world?
Well, so I mean, I agree with you, and algorithms are essentially they look differently. I mean, so I didn't show how you would do square roots declaratively, but it still looks rather odd because you still have to use an algorithm. You still have to use Newton. So I agree with you on one level that sorting algorithms are important, but on the other level, you only want to say, I want this thing to be sorted, and that I'm a strong believer that sorting should be a primitive of the language and not something that you program out, because almost all programming is based on sorting and searching. And I mean, well, so you know my background, but that's why ABC, you didn't ever have to write a sorting algorithm because sorting was a primitive of the language. And that meant actually that all programs ran much faster than anything anyone wrote by hand, because we'd spent so much time on the sorting algorithms in the system that it was much faster than anything anybody was willing to spend any reasonable amount of time on. It doesn't exclude writing algorithms, but it means that it's much less often necessary because most programming is administrative.
But you need some escape from the forms and the XML interface into the mechanism by which the 1% of the time you do have to write an algorithm, you can write an algorithm. Interesting one.
Up to a point. I mean, that was true of C as well at one time. That they needed an escape to be able to do everything they wanted to do, but eventually they came round to doing it all in C. And so at this moment, the answer is yes, you need an escape. But I think in the long run, the answer will be no, that once the optimizers start being able to deal with this modality, this paradigm, that you will still be able to do it efficiently without having to escape.
Hi, what is your opinion on functional reactive programming? Because it does appear there is quite a bit of overlap between the XForms declarative paradigm and things like React Native or Apple's Swift UI or what have you.
Yeah, I mean, it's certainly true that what XForms does, you can model in another language, and there's the famous saying that every large program contains a half-implemented version of Lisp inside it. You know, I think that a lot of things are converging on this way of thinking, and that's the reason I'm talking here is to expound on declarative and to give an example of one language that uses it and why it's been so successful, and just say that, you know, declarative in itself needs more research. There was somebody over here.
Thank you for your talk. It was very nice to me. And I was wondering about debugging. So it seems to me that people say, at least, that thinking imperatively is easy, and I would not know right now how to make up the debugging tools for, I mean, if something goes wrong there.
Well, so it was so in that system that we built in 1993, it was amazingly easy to debug because you could get to everything. Everything was just there. You could just make it visible. And we were just astonished at how little extra tooling we needed for debugging. partly because the program is much, much smaller. And I don't know if you know the rule that the cost of software is in debugging. It's 90% of the cost is in debugging, and the number of bugs in a system is a function is not linear with the size of the program, but the size of the program to the power of 1.5. So a programming language that reduces the size of the code automatically reduces the number of bugs to an enormous degree, so that XForms programs are typically a quarter of the size, which gives you about a factor of 10 difference. So where was I coming from? So you automatically get less debugging. Partly because you've specified the relationships rather than the code to achieve those relationships. There are no while loops in XForms, for instance. Because you've specified the relationships, those relationships are always kept up to date. And so you don't need a while loop to bring your relationships up to date. So that removes the amount of work you have to do, reduces the amount of bugs automatically.
Hey, Stephen. Thanks for this interesting talk. I used to work on Eclipse, and at the moment we could self-host Eclipse and use Eclipse to develop Eclipse. We got this acceleration going, boom. And when you think of Smalltalk being implemented into itself, and you can reflect on everything and redefine everything, that maybe sort of, you mentioned Lisp. Lisp is implemented in Lisp, but you can so could you imagine implementing XForms in XForms, and what would it look like?
I could imagine it. With that 1993 system I showed you, that was called Views, and we were halfway through that very process when the project ended, so we didn't have enough time to do it. But I mean, the way that you would do it was obvious. But it just needed more work than we had time for. But I could imagine it happening. It's still something we're working on, that sort of thing.
Because I mentioned it because it might give you a way of escaping. The first question was how do you escape from the system and redefine some of the underlying core elements. I think that you always need an escape mechanism.
You would still need an escape mechanism.
You always need
it,
yes.
You still need the right primitives.
Yes.
That's what you have to discover, is what primitives do you need in order to achieve what you want to achieve. Yeah.
Thank you for this talk. I just wanted to ask, you mentioned the relationships and you mentioned the size of the code as factors that make programming this paradigm so fruitful.
Yeah.
Could you mention maybe another factor, or what you think is the most important factor that makes this paradigm so efficient?
I mean, I think those are the two big ones. But if I was going to, so we designed this around XML, and so the data model is absolutely XML. My earlier backgrounds in the programming language ABC, which formed the basis of Python, we discovered another factor to give you more power, and that was the high-level data types. That loads of programming languages are built come with low-level data types, which you use to build high-level data types. But in fact, it's the high-level data types you need. You hardly ever need those low-level ones. And so ABC we built with a very high-level data types. And if you needed the low-level ones, then you sort of had to do something special. But it was the high-level ones that you really needed. And we reckon that gave you an enormous win as well. So if I were going to do XForms all over again, then I would probably redesign the data, the basic data types that it's built on. Time? 5 more minutes. Oh, any more questions? Yeah.
If we get back to this question about the kind of underlying algorithms that support your declarative language. It seems to me that that constrains what you can apply it to. So you've demonstrated XForms as an example for kind of these web interfaces and so forth. Is there a domain that you think that that would work on? Like, for example, I would think you probably need a different language for things like doing graphics or perhaps parsing spreadsheets or something like that. Am I right, or is it? So what's the link between like your underlying algorithms that come with the declarative language you've got and the domains where you can apply them to?
Well, I mean, it's been proved to be Turing complete. So I think that in the long run that there's no domain that it can't deal with as a paradigm. So I mean, graphics is absolutely not a problem, and that's already dealt with. The thing about parsing is that parsing is already declarative in itself. I mean, the grammar is actually a declarative specification of a parser in a sort of way. But there are no hurdles to being able to do that. And yeah.
I'm going to give it a try.
Yeah. Okay.
Yeah.
I mean, go to my homepage. Right at the top, there's links to a series of tutorials on and example programs as well.
All right, thank you.
Another question, if I may. You mentioned views, this 1993 system.
Yeah.
Presumably that's, you were working with Lombo Mertens,
Yeah.
and the constraint maintainers stuff
That-
came out of that.
That's right.
Which was a very early precursor of lots of work going on today on bidirectional transformations, bidirectional programming.
Right.
So you might have, you've shown examples with two different view components for the same model components and
That's
wanted
right.
to keep them in sync. More generally, and so both of those views sort of give you the whole story about the model, but more generally you have overlapping views of a model that is part of which is shown in this view, part of which is shown in that view, some of which is shown in both.
Right.
But neither has the complete story.
Right.
And the bidirectional transformations is about how to maintain consistency in that more general.
Exactly. Right.
Does that fit into this world?
It would absolutely. I mean, XForms itself doesn't have the bidirectionality that views did. In some senses, views was better than XForms, but in other areas not. But certainly, it was much more research material then, whereas XForms is really for production work. But the bidirectionality of views was an amazing discovery, and gave an enormous amount of power and surprising simplicity. And certainly that would be the following step for XForms, is to introduce bidirectionality into the constraints. Yeah.
Okay, thank you so much, Stephen.
Thank you.
Thank you.